Welcome to a lesson with Dr. Powell. Let's take a look at how we can compute this integral right here as we set up in the last video. So what we can do is we're going to change this to polar coordinates, hence the change from dx dy to r dr d theta. We use the equation of a sphere, which can be thought of as r squared plus z squared is equal to 4, radius 2, because we can think of r squared as being x squared plus y squared. And in particular, z squared is equal to 4 minus r squared in that particular case. Remember that r is going from 0 to square root of 3, theta is going wrapping all the way around. Now, using this idea, we can take this, add fractions x squared plus y squared over z squared, which looks like r squared over z squared. Add fractions again and take a square root in the denominator. Get something like this. Now, this right here looks like from this equation, we would get a 2. And here the square root of z is just this. Keep in mind that z in this area of the sphere is positive, so hence we have a positive square root. Okay, so this is kind of what we get down to with this part. Now, also recall that we have an r dr d theta, so we can put an r right there. And then we're integrating right now. Okay, and we're integrating with respect to r and theta, so this is a double integral. We'll put a 0 to 2 pi for the theta and 0 to the square root of 3 for the r. Okay, we can use a u substitution. Make this u, and so that means we can replace our dr with du over the derivative of u, which is negative 2r. So we have a negative here. Now, to account for the negative, we'll just switch up the bounds. So the 0 here, so when r is 0, that's going to now be on the top when we kind of switch the bounds if we want to account for that negative. So when r is 0, we get a u being 4. So now that'll go to the top. Now, when r is square root of 3, it accounts for u being 1. So now that'll go up at the bottom. We did this little switch with the negative. So now we won't put the negative in since we did it with the switch. Then we have simply u to the negative 1/2 du. And then the integral from 0 to 2 pi of theta just amounts to multiplying the whole thing by 2 pi. Okay, now in this part right here, taking an antiderivative, we end up getting 2 u to the 1/2. 1, 4, stick in 4, we're going to get a 4 out of that. Stick in 1, you get a 2 out of that. Take the difference, you get 2. So this integral right here is just 2 multiplied with the 2 pi, gives you 4 pi. So we've just computed that the surface area of the top cap right here of the sphere is 4 pi. Thanks for watching.